Argon is not one element that we are going to find in pigments, though the spectrum of argon, the peak K-alpha of argon, is going to be often at least present in our spectra. This is the reason. Air is a mixture of gas. So basically, mostly we have nitrogen that is over 70%, then of course we have oxygen over 20%, and among the other gases, the most common is argon, about almost 1%. What happens is that when we analyze an object in air with our XRF spectrometer, the argon in that air will be hit by X-rays from the tube, and so it will emit X-rays on its own. So we will see the specific peak of argon at 3 keV. Then there is the K-beta 3.2, but generally we don't see that because already the peak from argon is pretty small. Okay, so basically we barely see it, the K-alpha, definitely we don't see the K-beta. So the first experiment is using the HDPE plate, so the high density polyethylene plate. This material, again, remember, acts as a mirror, so the X-ray tube from here, then they are reflected from this material that doesn't have any element detectable with XRF, and the signal goes, these X-rays go into the spectrometer. So let's do the experiment using the 3 different filters setup. So we start with the no filter setup. So no filter inside the tube. Remember, this method is useful for X-ray lines below 3 keV. So you see, in this case is the black spectrum. Over here we see these 2 peaks. One is rhodium, so it's the tube itself, the target of the tube. In our case we are using a rhodium target. Then this one at 3 is the K-alpha of argon. So in the case of no filter setup, the lines of argon is pretty strong and intense, so we are almost at 4000 counts. Then when we use the low keV, in this case you see the peak of argon is present, but definitely much smaller, so it's barely visible over here. Then when we use the routine blue spectrum, in this case you see the peak of argon is not visible at all. Okay, just to double check, we can do the same experiment using a metal. So we have bismuth tube over here, and from the analysis we see bismuth without any filter on the tube. This one at 3 keV is the argon peak at 3000, so it's the same intensity that when we use the HDPE plate. Then when we use the low keV filter setup, we have, when you saw the red one, a very small peak over here. When we use the routine filter setup, the argon peak is not visible. So definitely argon plays a big role in no filter setup. As usual, I wanted to make a baseline for argon to see the spectrum of argon alone. I bought this one, is an argon vial, so we open this one and inside there is this glass containing just argon. Unfortunately, I tried to measure it, as we see here, under the spectrometer, but I could not get any signal from argon as expected, because the glass containing this argon, it's thick enough to stop the X-rays at 3 keV. So they are stopped by very thin glass, so we could see that from the online calculator for the attenuation. We can do an experiment just to check that inside this vial there is actually argon using this plasma sphere. So we will put this argon close to this plasma sphere where there is a potential inside, and so the gas also inside the vial will be excited, emitting the typical color of argon. Put the vials close to the bulb, and you see there is some discharge. There it is. We have this violet color that is argon discharge inside the vial.